Everyone. I will try to share the experience Volvo have in how we work with sustainability and a little bit more specifically how we use that when working with polymers and plastics, and also a little bit about the challenges we see with recycled plastics that have to be overcome, because we're a strong believer that the recycling of plastic and the reuse of plastic components and materials have to increase. I'm going to see if I succeed in sharing my screen here. Please let me know if you see a car on a pier. And now let's see if we manage. A little bit about Volvo, just for those who are not too familiar with the company. 2020 was a strange year for everyone. So 2019, we sold 700,000 cars. We actually, during 2020, almost did the same. We have roughly 42,000 employees worldwide, and we have manufacturing operations in the US, in Belgium, in Sweden, and in China. We also have product development in predominantly Sweden and China, with some offices, smaller offices spread around the world. As a company, we actually have three ways we sell cars today. We have the traditional sales of cars, where you as a private person or a company buy one. We have a subscription service called Care by Volvo, where we own and maintain the car and you subscribe to it just as you would do to Netflix or any other service-based product. You pay a monthly fee and we cover the rest. And we also have launched now in a number of European cities a service called M, which is a ride-sharing service where you, through an app in your phone, can book a car for anywhere from essentially 15 minutes up to a couple of weeks if you want, and you pay as you go. So we're trying to transition our business a bit away from the only having the traditional way of selling products linearly, which we also believe actually is not the best way to work from a sustainable point of view with the use of materials. We also have a relatively new brand that's arrived from us called Polestar, which is a fully electric brand. And together with our owner, Geely, we are launching a separate company called Lynk & Co, which the basic concept of the Lynk & Co cars is you cannot buy them. They are only available as a subscription service. So we're trying to diversify our portfolio, but also the way we make business here for the future. So Volvo has historically always been known for safety. In essentially every ranking worldwide, we tend to come up top in safety. But what we did in 2019 was that we, as a company, all the way from our board of directors and CEO, said that sustainability has to be on the same level of safety. And so what we say is we commit to the highest standard of sustainability to protect the world we share. And it might look like, well, another strategy document from a big company, we've seen them before, but this has made a significant impact internally in the amount of money, resources, time, and how we make decisions. So there is no major decision on technology or future product lineup that isn't very much considered from a sustainability perspective these days. And one of the easiest examples of that I think we can show is that we have committed that by 2030, we will only sell electric vehicles. So no combustion engines will be available. And as the sales development is going right now, I'm starting to wonder if that might not even take place earlier, because the customers are transitioning very fast into new products. So why are we doing this? I mean, we're a company, we're in it to make money in the end, we want to be profitable. I think first and foremost, we realize as a company that if we do not take sustainability very seriously, especially in a carbon intensive area as the transport sector, there simply won't be a long-term business. So we've made commitments about how to be climate neutral and how to transition our business into a more circular economy. We also see a huge pressure from regulators who are increasingly concerned about the societal effects of climate change, rising water levels, changing climate, temperature, living conditions for the citizens. And this also is transferred then to consumer expectations. If you're doing what to many people is the second biggest investment after a home in their life, then they want to know that the decision they have made is both to themselves and to the people who view them is a good and a conscious decision that they can justify and live with. We're also starting to see a huge interest actually from younger people when they're looking for the first job. They are much more selective about which companies they're willing to work for. And we have actually, due to our move to electrification and our move towards sustainability, we see a huge increase of what I would essentially call top students around the world who actively want to work at a company with this profile. The last thing that actually isn't fully mentioned here is the investment community. We work a lot with investor relations, and the investment, the joint venture in the banking, the investment in general is very increasingly concerned about sustainability. And to the point that we are starting to see companies in, for instance, the petrochemical industry, who are not getting the investment and the loans they're looking for simply because the industry is worried that their business plan isn't sustainable enough, that they're not doing enough, and that climate regulation and climate change will catch up with them, and therefore they're moving elsewhere. So we have seen a huge influx in interest in basically green capital that are willing to work with us that other industries simply cannot reach. So this is it's both an ambition as a company, but it is also sort of the only financially sound way you can run a big company today, is to strongly increase your focus on sustainability. What we've committed to, as I said, we will have only electric cars by 2040, and we aim to be a climate neutral company by 2040. And for a company who sells cars, that is, I'm not going to lie, it is a big challenge. When we say climate neutral, we also exclude carbon offsetting, such as paying to grow forests and similar, because those tends to be not real carbon offsetting. They tend to be more prolongation. The forest might be there for 20 to 30 years, but then it's going to get cut down anyway, and you haven't actually sequestered any carbon. So we say that it has to be truly carbon neutral. To start the ambition, we set a number of interim targets towards 2025, where the most predominant one is a 50% reduction of tailpipe emission, which mainly comes from switching over to electrification. But what you can see in this slide is that the left bars are the reduction we do in emissions, but the other bars are environmental impact and carbon impact we have, no matter if the car is used or not. So the usage and extraction of raw material and resources, logistics, production, office facilities, and so on. And they actually make up a significant amount of environmental impact, no matter if you measure it from a life cycle analysis perspective or just from a carbon impact perspective. So we cannot just say that switching to electrification will take us to the target. We have to do a lot of active work in material selection, material sourcing, the circularity of our materials, and that's where plastics come in to be a very interesting alternative. Now, a simple way to explain this, the impact, and this is actually not specifically linked to cars, it's very generic, is that roughly 45% of your impact of products that go in a household comes from the actual design, production, manufacturing, service of the part, and 55% comes from energy usage. And this number, when we do life cycle analysis, very much adds up quite well to a car as well, that roughly 45% of our environmental impact today comes from actually making the car all the way from design and then servicing the car, using parts to service it, and end of life process when we recycle the vehicle. So we have a huge focus on how we work with materials and how we can change the way we work with materials. And that is what I will hope that I will show you in the coming slides. Now, just to understand a little bit, when you look at a vehicle and the materials that go into a vehicle, we say that plastics or polymers, as we see here, is the small yellow section up in the top left corner. So you can see that aluminum and batteries and steel are the three biggest impacts to climate or CO2 load or climate impact from the materials that we put into a car. But polymers still have a very interesting aspect from an environmental point of view. And I've heard in some of the previous presentations here today that where it's mentioned that the European Union currently is only recycling roughly 10% of all the plastic waste in Europe. The rest goes to incineration or even worst case landfill if it's not well controlled enough. And there is a huge ambition from a regulatory perspective in something called the Circular Economy Action Plan in Europe, that this is no longer acceptable, and we need to raise the levels of recycling, and we need to raise the levels of recycled content going into new products. So when we look at plastics and when we look at carbon impact like this, it's not that we disregard plastics just because there are other areas, because approaching aluminum and approaching steel is not so much to do with the actual material and how it is the chemistry of the material. It is about changing the energy source in producing that material. But when it comes to plastics, there is so much more we can do with the actual production of plastics and how we use them and how we take care of them. So there are other sources there that become interest. And I've listed just a few, and we'll get deeper into this, but how it lasts over time, durability and degradation, how the waste flows for the plastic looks, even either as a source to us or what we do with our own waste. And was something that is becoming increasingly important is what is the raw material source? Is it a virgin material made from oil? Is it from a material recycling? Or is it even reuse of different types? When we look at this and work with this, we've sort of divided it into, just as we did with CO2, in two steps. That towards 2025, we set a number of targets on materials and components, but they are very much looking at the traditional way where you sell a product to a consumer, the consumer uses the product until they don't want to use it anymore, and finally it is scrapped. And in most countries, that means that it goes into a regulated recycling process. But in some countries, it is essentially a free market approach to recycling, and you can see different in targets and how efficient the recycling process actually gets in that way. Europe, together with Korea, Japan, has the most strict recycling targets in the world, where you look at roughly 95%. US is actually a pure free market setup, and there the material recycling, I would say, is 3 to 5% lower, depending on where in the US you are. So we have defined 3 principles that we work with, and all of them, I would say, apply slightly different to how we use plastics. So we're looking at creating more circular materials. And if you read in the left box, you can see that we have made an ambition towards 2025 that 25% of our plastics should either be recycled plastics or they should be made from renewable sources. And you can also see that we strongly believe that this is not an additional cost to us. We can actually save money from this. The next area, the middle box, is talking about retaining component value. And that means refreshing and refurbishing components, or taking them back and basically remaking them into the same component again. We have done this historically for things like engine and gearboxes, but we're starting to see other potentials where we can do this. And the last one is called capture business benefits of circularity. And here's where we're looking at things like when you have crash damage of a car and the insurance company fixes the car, the part is just waste to them. But if we instead had a cooperation where we could take this, which often are fairly new parts that are not that old, and for instance, take bumpers and grind them down and remake them into new bumpers, instead of just sending them into a generic plastic waste flow, we can minimize our raw material cost. We can also improve sustainability and lowering the cost at the same time. So right now, we are in a period where we have identified all these targets. We have set the targets internally, and now we're doing a tremendous amount of engineering projects and advanced engineering projects, mainly together with our suppliers, but also largely with material suppliers. And what we're seeing here, there's a large number of, if I would say, smaller and new companies that come up with brilliant ideas on where they can collect a raw material source, or how they can cooperate with, for instance, our own waste streams to bring that back in terms of raw material that meets the same quality and the criteria that we normally work with. So mentioned these, I'm just going to skip through them and go a little bit more than in depth on plastics and how we view plastics in our industry and how we work with them. So just a simple overview. This material breakdown here is for a Volvo XC60. That is our most sold car that we have. And it's today available as either a petrol engine, a diesel engine, or a plug-in hybrid. But in terms of plastic content, that doesn't make much of a difference. The car has roughly 300 kilos of plastic in it. And the breakdown percentage-wise is, as you can see here, the most common plastic is polypropylene, which is used for bumpers, for panels, most of the hard plastic parts. Then we have PA, which is normally mixed with glass fiber to make structural components, PCABS, PVC used for instrument panel cover. We're having some vinyl, and we're actually increasing the amount of vinyl. We have polyurethane that is very much used as a technical property material. For instance, the instrument panel has a lot of safety requirements on it in terms of crash and impact and energy absorption, where polyurethane makes a very good use. We have it in a few other areas as well. And the list essentially goes on here. But here you can see the breakdown of what we're working with. And as I said, the ambition is that from 2025 and onwards, 25% of the total amount of plastics here should either be recycled or made from a renewable source. I took some examples from other industries just to show that this is not Volvo is not a unique OEM in identifying the needs and these issues. But the good thing I found when you look at public statements from our competitors is that we are actually the ones who take this the furthest. Ford is talking about reaching 20% renewable and recycled plastic by 2025. PSA, Peugeot, which is now in a new constellation with Fiat and Chrysler, and the new name is Stellantis. They talk about a minimum of 15 kilos, which honestly speaking isn't that much. Daimler is historically very vague in their communication. We know that they mentioned that they have roughly 30, 40 kilos recycled today, but they won't commit to a number. Renault is tremendously good on circularity and reusing materials, but they are still a little slow on committing to actual numbers. And as I said, Volvo then looking at 25%. And the good thing is, of course, that puts us on top. The difficult part is, even though we sell 700,000 cars and we're growing, we are still a small customer in the automotive industry. So if you compare that to Volkswagen or to Daimler or to Ford and GM, we're at 10% of their sales. So if we come with very unique requirements, we struggle a bit with our suppliers. And what we have learned is that to a large extent, we sometimes have to find our own suppliers, unique suppliers to us, to actually make these solutions happen. Looking at how we use recycled plastic, we unfortunately, or regretfully, I will openly admit that the most we use today is post-industrial recycled plastics, not post-consumer recycled. The difficulty with post-consumer recycled materials is getting a continuous source of material that we can rely on. So if we source, I'll take an example I'll get back to later, using PET bottles to create a yarn that we can use in the textile upholstery, we need to know that we have a continuous flow of that material available for at least 5 years to do the long-term sourcing and do the planning of that. We cannot build a car based on that we can buy a batch today and then not know what we will have in 6 months, because there's a tremendous amount of quality assurance and requirements on essentially each part going into the car. And that has led to that today, post-industrial waste is more easy to control, more easy to find, and therefore it is also what mostly has been used. So what that means is that we, as a collective, we, our suppliers and the material suppliers further down in the supply chain, need to work more on the logistics, but also the data and knowledge on post-consumer plastics to actually reach our own targets. We also run into some of the issues that was mentioned here before on how can you have consistent color, how can you have consistent surface texture and so on. if your raw material differentiates over time. And I will get back to this, but there's a number of technical requirements that also have to be considered. So when we look at recycled plastics and think about how we want to use them and how we can use them, there's sort of a number of prerequisites. And one thing is that it has to be, we want to increase the reuse of recycled plastics, but we can't do it if our overall environmental impact does not improve. So if the logistics, if the warranty, the amount of parts we have to throw away or replace and so on, outweighs the environmental gain of using recycled materials, then we actually haven't achieved the goal of improving our sustainability. So we're looking at a lot to use life cycle assessment. We work with suppliers on our major components to do life cycle assessment and compare the difference between using the virgin material that I've historically done and then switching over to recycled materials. And what this means is that the suppliers we work with have to be willing to be very transparent on their material, the material source, and the benefits and disadvantages of using these materials. And so what we see, and that's why we haven't committed to a target already, is that there is quite a transition period to find the data, to find the suppliers, and to set up the processes where the information flow will work so that we can verify that the use of recycled materials is truly a benefit. And we have a lot of suppliers who approach us with great ideas, and some of them unfortunately fall short in being able, the idea sounds very good on paper, but it has been difficult to prove. So this is what we're looking for when we're looking for partners in this. And we see that there's development both in ISO and in different regulatory bodies for the automotive industry to try to standardize this more, to make it easier for everyone involved. And the overall purpose of this is to hurry up the transition into more recycled material. What I also can say, this is a picture from a Volvo concept car, and normally that where you see the recycling logo, this is on a driver's seat, there would be a little Swedish flag. We normally wanted to symbolize the Swedish heritage, but we see more pride and consumer impact from talking about how you're helping the overall environment than just talking about that the car has been made in Sweden. So this is not unique to Volvo. We see most of our competitors are talking quite a lot about this. Audi has been very active lately, for instance, in talking about how they use PET bottles to make upholstery. And so this is becoming a competitive subject where we are competing for the same good recycled material. And what I want to just point out here is that there sometimes is a risk for what I would call sub-optimization. Right now, there is a tremendous interest around PET bottles. And unfortunately, PET bottles, I know, is a huge waste issue. Especially, we have a number of Thai companies who have approached us saying that they work with the local fishermen to clean beaches and they can provide the source. The question, of course, is should PET bottles become PET bottles or should they become vehicle upholstery? We have to make sure that the flow of materials we create is beneficial to the overall sustainability and doesn't just become a marketing stunt to us. And that's again why access to data becomes very important to make the full assessment. Talking a little bit about requirements. There are many areas where we see that you easily can use recycled plastics. Cars is not one of them because cars are heavily regulated. And if we just look at plastic parts, the most difficult flame or fire requirements are in the US. The most difficult odor requirements are in China. Recycling targets, Europe, and we build these cars globally. So we have to make a car that meets the fire requirements of the Americas, the odor requirements of China, and so on and so forth. And that leads to a very long list of requirements. Most of these requirements are not just there because we want them. They are there as regulation, meaning not only do we have to plan for them, we have to prove to an authority in order to sell a vehicle that we can meet these targets. And that's why a continuous flow of a stable material is so important, because we cannot certify a vehicle and then 6 months later completely change the materials going into that car, because then the certification is no longer valid. So we end up having to work very much in a large scale approach, and we need to have very strict specifications on the materials we work with. And as I mentioned here, the product has to work globally, and unfortunately, with, for instance, Dieselgate that happened in the US, where there was cheating on the emission from certain OEMs, there is a lack of trust from authorities. So they will continuously test our products, and it's not enough that we just say that something can meet the requirement. They will absolutely follow up on that, and that's why it becomes so important, the flow of materials. We also have sort of a technical constraint that we are continuously getting more and more requirements coming on our parts, either from internal requirements in weight savings or performance gains or design changes, but also in terms of regulation. And at the same time, a polymer in most cases degrades over time. So there is sort of a very simplified graph you can draw like this, that the technical requirements on the new part that you will make from recycled material will be higher than the original part that the recycled material probably came from. And at the same time, the quality of the material tends to have gone down over time. So this is a challenge that we're trying to find solutions for and working with. And to exemplify this a little more, you can look at different areas of the car, as we've tried to visualize here, and you can look at the different technical challenges that you run into. So if you look at external body parts, they have to be painted, they have to be durable, they have to be resistant to UV radiation and sunlight. They should hold well, they shouldn't break easily, they shouldn't become brittle over time. If you look at interior parts, color and texture becomes incredibly important from a consumer perspective. Odor and emissions, nobody wants to be in a car that smells bad or gives you a headache. And then it has to be durable from a different perspective. And then technical applications, structural components, and so on. There's a lot of focus on weight, but also that they can be load-bearing, that their tensile strength is high enough. So there are challenges here, and we're not trying to shy away from them. We're not using them as arguments to not do it. As we've shown, we're trying to rapidly increase the amount of recycled materials. But these are the challenges that we face and need to work with. And that's why when we find the material suppliers, we often have sort of a long list of requirements we have to go through. And I just want to visualize that. And despite all these requirements, we are finding a number of good examples with both traditional suppliers, but also a large number of new material suppliers that can meet our targets, which leads us to believe that the target we set towards 2025 is definitely achievable. So to summarize, the world is changing quite rapidly, both unfortunately in terms of climate change, but also in regulatory and consumer reaction to that, and wanting to do what we all can to stop this, which has a huge impact on the type of product what we can put on the market. As a response to that, we've said that we have to make sustainability our highest priority as a company. There is nothing that is more important today. And there are a number of efforts, both on type of products we sell, but also the materials that go into them. So what we've done is set a number of strategic initiatives in different areas, such as electrification, but also in material and component lifespan, durability, recyclability, and reusability. And those were the examples I've shown. And they will continuously be revised as we will raise our bar for what we find acceptable. So we will definitely have more strict targets coming after 2025 in the material area. Looking a bit specific more on plastics, as I said, while there is a joint effort from the industry, it is also a competitive issue. And we have to make sure that we are not sub-optimizing something to put in cars that actually would make more sense somewhere else. So there needs to be a scientific and life cycle based approach to this. And it has to look more than just CO2 impact, because that tends to unfortunately oversimplify the issue. A car is a very durable good. It's probably one of the more long-lasting consumer goods that you will buy. And there is issues in using recycled content, as I mentioned, with aging over time and increased durability and regulatory requirements. And that's what we jointly have to work to overcome. And that's why we are looking much more at working with suppliers than buying from suppliers in the future. And no matter how much we care about sustainability, we already know that the technical requirements in terms of safety, in terms of design, and in terms of technical properties of the material will continue to increase.